Hi, my name is Stacia Conger. I'm the State Irrigation Specialist with the LSU Ag Center, and I get a lot of questions about micro-irrigation or putting in drip for landscape beds. And there's a lot of different options and a lot of things to consider, and so I thought I'd put this video together to show you some different options and some considerations. This landscape was damaged by the freeze and has not been replanted. You can tell that all of the sprinklers were set up for a different style of landscape. It's very difficult to update sprinkler systems like this, and they're very static systems. Whereas a drip or micro-irrigation system can be very dynamic and help target water to the plants where we need them. The first step is to find the products. I got a kit, but if you're doing a larger system, I would recommend going through an irrigation distributor. First, we're going to lay out the stuff that we purchased at the big box store. Here we have a micro sprinkler landscape and shrub kit. I've also purchased 2 gallon per hour dripper, a 1 gallon per hour dripper, and a 1/2 gallon per hour dripper. I've also purchased some bubblers in case we need that type of application as well. And this is what came inside of our kit. You can see that we have 5 stakes with micro sprays and the vinyl already attached to them to directly plug into the drip tube. We also have everything we need to get from a hose faucet on the wall to an irrigation system in completion. I want to point out that everything is color coded, and so the different nozzles have different colors to them, as well as the drippers are color coded based on their application rate. And this will be key in the future when you no longer have the packaging. Now we're going to lay it out so that we can see everything that we have. This device is a backflow prevention device. It's called an atmospheric vacuum breaker. That means it has to be the highest point of any downstream water application that you have, and it should be at least 6 inches higher. This is the next piece of equipment that's going to connect the drip tubing to the backflow preventer. And so they just screw together. And then the drip tubing is inserted into the bottom by pressing in and then twisting the connector tight. At the other end of the drip tube, when you have completed the system, you will end the system by using one of these clips that slides onto the end of the tube, and the tube is just folded over and the clip is inserted on both sides, and pinching it this way helps to stop the water from coming out the end. The next step is to hook the backflow preventer to the faucet. After making sure that everything is securely fastened, we can run the irrigation system. Each micro spray nozzle is very different. You'll have to pick your nozzles based on the application rate that you need, as well as the radius or throw from the nozzle that you want the water to reach. This will also be dependent on pressure. Micro-irrigation is very dependent on the intended application. This will determine how much water you need and where you need it. Application rates are normally listed in inches per hour for micro sprays or gallons per hour for drip emitters. They're related based on the equation of volume equals depth times cross-sectional area, or V equals D times A. These are some common conversions that are needed to convert between these different values. When we want to determine our depth or volume, we look at replacing evapotranspiration. This is something that you'll have to know how much water you want to apply when you want to apply it. Your area is based on the area that the circle reaches. Every microspray has a certain radius, and the area is calculated as pi r squared for a full circle. Those values are ratioed based on the angle to a full circle to get the proportion of the area. The precipitation rate is calculated as the flow rate divided by that area. And you can get those values from the manufacturer's specifications. Here, the manufacturer lists precipitation rate directly. The runtime, or the amount of time you're going to run the system to get the appropriate amount of water, is equal to the depth that you want to apply divided by that precipitation rate. So as an example, I have a tree that needs 1 inch of water. So I would run the irrigation for this specific sprinkler that has a precipitation rate of 0.47 inches per hour for 2.13 hours. For drip emitters, my runtime is going to be related to volume. And so my runtime is my volume that I need to apply divided by the flow rate. So if I have a 10-gallon pot that needs a gallon of water, and I'm using this red drip emitter, which from our literature said that that was a ½ gallon per hour application, then to get 1 gallon of water, I would run the system for 2 hours.